should have all begun preparing. I hope you all have. Remember that I've already gotten one question about this, so I want to make sure that everybody is aware of this. Remember that there are some details of this class that we have not spoken about explicitly in the lecture, and that you may see those details on old exams. And in those cases, you shouldn't assume that those old exams do not or cover different material than this exam does. This exam covers every bit the same material that those old exams do. And if you see something like that, that indicates that there's something that we didn't cover that will be or could potentially be on the exam. So be aware of that, and be ready to ask questions about that on the review session on Wednesday. So again, the review session on Wednesday will be during class, and it will be basically a question and answer session where you can ask me any question that you have seen in the course. I won't answer questions related to the second and third exam just because we want to stay focused. The session will end if we don't have any subsequent questions, but I'm sure that you guys will have plenty. So work on those previous exams, work on homeworks and other previous homeworks and labs that you have, and use those as places to figure out where you have open questions. Because if you have open questions, I can definitely address those open questions in the session on Wednesday. The other thing is that later today I will be posting the answers to the existing exams that are up on cse2.uti.edu. So if you've already started doing those exams, then you'll have answers to check your work. But please understand that if you're writing code or you're doing anything to work on these exam questions, you can already check your work. Just code it into codeanywhere.com. You have the resources to do that. In fact, it's a much better way to check your work than it is to look at the answers, because the answers are just a single instance of a solution to that question, and you can try all sorts of variations on those questions if you test it out on Code Anywhere. And that's the way that we learn how to code. We practice by testing things out and seeing how it works. Okay, so today we'll cover our last important topic before the exam. And if we have any extra time, I'll take any questions now. But we'll have the full session on Wednesday to have those questions. And another important thing that I want to say before we have this first exam, I try very hard in this class and try to control expectations for that exam, because the first exam is a big hurdle for a lot of people. It's not that this course is actually cognitively difficult for anybody in this class. I personally believe that this class is a class that will eventually migrate out of college and become a senior level course, a junior level high school course, and eventually sort of settle in middle school. Now, the reason why you find that surprising is that you have all been trained with all these other imaginary prerequisites. This class doesn't require calculus, it doesn't require geometry, it doesn't require algebra. It only requires logical thinking and some practice with some new ideas. If you learn those ideas when you're young, why not do this when you're in 6th grade, 7th grade? You guys are all capable of this. And so there are two things that I want you to take away from this. Your preparation for this class has everything to do with your becoming familiar with these ideas, just like you became familiar with algebra and geometry and calculus, all those things that school systems made you learn that you don't use right now. The same thing is true for this class, except that you will use these ideas all through your college education, and if you continue to become software developers or people who use software every day, you will understand these concepts and be able to exploit them. I think you will all look back on this class and think of this class as easy. You will see the first exam and you'll be like, this was easy. But coming up to that first exam, it's going to look like a huge mountain, especially for those of you who haven't started looking at exams already. It's going to seem like it's inconceivable how all of this stuff could be focused in on a certain exam. It looks like there's a lot of material, and it also looks like it's very foreign. And And that's inevitable, right? We all remember our first algebra test in high school, or our first calculus test in high school. Calculus at one point seemed insurmountable also, right? So just remember that your wiring is not incapable of dealing with this. It's just a new idea. And I don't know about you guys, but I always had that regret. I was kind of a B student in high school, so I always had that regret that I could have totally aced calculus or aced a number of things that I got B's on because I didn't prepare. And looking back on those things, it's like I could have totally gotten an A in geometry because geometry wasn't all that hard. So think of this as your opportunity to not trip on that thing, because it's really just preparation. And I assure you that with the right preparation and with consistent preparation, you will do well in this class. Another important thing, let's take it from a more cynical perspective. This class is, I've noticed that not everybody looks at the syllabus and how much the exam and the homework and everything is worth. Right? So let's break it down. Homework's worth 20%. The exams are each worth 10%. And the final exam is 25%. There's also attendance and lab attendance and class attendance and lab completion and things like that. So the 3 exams worth 10% and the final exam worth 25% are worth 55% of the class. So that's about half the class. The homeworks, the labs, the attendances are easy to get 100% credit on. And you should regard those as a buffer for your grade. Maintain a very high score, above 95, above 90. That's a big high average that you can count against. So if half of your grade is 98 and the other half of your grade is 55, you're still making low 80s in the class. And then for the total class score, right, your final average, that is curved in this class. So when I curve this class, I'm looking I'm not looking exactly for a bell curve. I basically take the students that are outperforming, the students that are always at 100%, I don't count them in the curve, and then I curve the rest of the class. So there's always some people here who probably shouldn't be here, so they have 102 because of something. I count them out, and the standard scale that's applied to the class is about 5%. So if you think about your average, if you have, let's say you have a 78 average between your 95% homework average and your 50% exam average, and you have, okay, well that's 50% and 98% gets you a little bit below, in between 70 and 75, right? So you add 5 to that and you're in the high 70s. That's a B- in this class, okay? So in terms of damage to your GPA or whatever, you don't need to be so scared about this class damaging your GPA, because I don't think everybody's going to get a 55 or less on the exam average. In fact, from 4 years of experience teaching this class, I know that you won't all get 55 or less on your exam. So don't be afraid of this class, but you do need to focus. And if you put the effort into this, it will not only teach you how to prepare for these things as a developer, but it will also make sure that you excel in the future classes. And recently, I've privately seen some evidence of performance of my students in subsequent classes in CSE 17 and CSE 109. They all do very well. And I believe that you guys will be in that cohort as well. Okay? So review session Wednesday. Okay, so I've had a number of questions, and I always am forced to leave this topic out for the last lecture because it's always good to have it in addressing other people's questions, because now some people have seen this issue. And we didn't talk about it in class, so we need to talk about it. And sometimes, when we have code that looks like this, maybe you're checking rental car ages or whatever, you have your age, maybe you got this in from a scanner, maybe you just hard-coded it. You check the age, and then you declare these 2 variables inside the if statement, and then you try to print out those 2 variables, or one of those variables. And it looks like this code is totally legitimate. What's wrong with this code? I declared it, I assigned it, I'm accessing it after I declared it and assigned it. What's wrong with this code? Does anybody want to answer that question? Yes?
It's only going to declare rent rate if your age is over 25.
That's right. So rent rate is only conditionally declared in this code. Some people came up to me in lab and they said, like, why is it that, that this isn't initialized? Other people asked me, like, why isn't this even declared? These are two variations of the same thing. Java doesn't know if your if statement is going to execute or not. It doesn't know if my age is true or if my age is false. It just knows that you have an if statement. So as far as it's concerned, both things can happen, and it has to plan ahead for both possibilities. So that means that it will assume that if can rent car is not declared outside the if statement, then it doesn't know what can rent car is outside the if statement, because everything inside the if statement is only conditional, right? It only happens sometimes. So in this case, rent rate is only conditionally declared because it's inside the if statement. And because it's only inside the if statement, it doesn't necessarily know what rent rate is, and therefore it doesn't know what to print out. So this notion that something is only conditionally declared carries on to the way that we treat all containers of code in general. And that is, we call them a scope. A scope is a very special word. It's a terminology for where in the code a variable is viable or declared or exists. And we'll see some examples of that. Okay, so when we see this problem, let's take a step back. When we see this problem, we get this error from the compiler. Now, one really good thing that the people who asked me about this question, one practice that's really good that these people who asked me about this question are doing, and one thing that I suspect all of you are doing, is that when you have a problem, you're reading what the compiler says. Now the compiler, it says all sorts of things, and sometimes it doesn't help you. In fact, as you get more and more advanced in your software development, you realize the compiler can't tell you what is wrong with your code. The compiler can only really just complain. And you have to sort of like analyze its complaints to figure out what the actual problem might be. So I want to start you on that practice now by reading this error so that we can figure out what exactly it means. So the compiler throws us this error. It says rent rate cannot be resolved to a variable. So it's referring to this variable named rent rate. Okay, so it knows about this thing that we were talking about, rent rate. And it knows that it's looking for this variable. So it knows that rent rate is a variable. It has an identifier here, and it's referring to a variable, so that's good. It doesn't think it's something else. And it's trying to figure out what this is. That's what cannot be resolved. You can think about the compiler as reading some foreign code, and the compiler is trying to figure out, like, what was that user talking about? What was that programmer talking about? And in this case, cannot be resolved means that it can't figure out how you're going to refer to a rent rate as a variable when it doesn't know what variable it's talking about. And this is the disconnect, right? You know that rent rate is supposed to be this variable here. You can see that you clearly declared it right here. And it's complaining about this line, the print line, about not being able to resolve this variable rent rate. And that should indicate to you that there's something wrong with how this variable has been declared. Another way of looking at it is that you can look at this print line statement and you can look at everything in this print line statement and tell there's nothing wrong with the print line statement, right? So just like in that first lecture in the class, when we would look at everything in that one line to see what was wrong, we can do that in this line and find actually that there's nothing wrong with this line. So then we need to backtrack. Like, what else could be causing this problem? Well, the first place where we would look is the last place we used rent rate. And in that case, it's this line here. At that point, we would notice that rent rate is in a different scope. It's inside the if statement. And that means that inside the if statement, it only exists inside the if statement and not outside the if statement. So I'll talk a little bit more about scope in a second. Okay, so how do we fix this problem of variable scope? We fix this problem by declaring rent rate outside of this statement. That's one thing. So First, if we declare rent rate before the if statement, then it exists in the exterior scope rather than if inside the conditional scope. Right? So the scope of this variable is now all of the code that we see, and not simply inside these curly braces. And that's really important because now it can be accessed using the print line statement. Now here the code still has a problem. The code still has a problem because there's that second thing that people were asking me about in lab that I mentioned just a second ago. That it can also say that rather than being conditionally declared, the code is the variable is conditionally initialized. If the code is conditionally initialized, that means that sometimes you have assigned a value to it, and sometimes you haven't. And if it only sometimes has had a value assigned to it, then what you really have in your code is sometimes when the if statement runs or when it doesn't run, you have a variable that is declared, never assigned, and then accessed. Other times you have a variable that is declared, assigned, and accessed. But because of the if statement and the fact that Java doesn't decide whether or not it runs, sometimes it is declared and accessed immediately, and that's not okay, that's a compiler error. So Java will say, well, you haven't initialized this variable. To initialize a variable is to assign it for the first time. So in this case here, we've moved run rate into the right scope, but we have this other problem. It's not correctly, it's in this outer scope now, but it's not inside, it hasn't been initialized. We have to fix this problem by initializing run rate. Excuse me for skipping slides. I'm not skipping because I'm trying to confuse you. I'm skipping because I'm talking ahead of my slides. If you need me to step back for any reason, let me know. So the way that you resolve this problem with rent rate is that in addition to declaring it in the outer scope, you need to also assign a value to it or initialize that variable. So initialization is giving a value to a variable for the first time. And what you're doing here is you're giving it this default value 0. And you're assuming that if the if statement is triggered, then you will change this value. But if the if statement is not triggered, then you'll just leave it at 0. And that's how it's going to work. Now, even if this if statement has an if and an else clause to it also, an else component to it, and that else component contains an assignment to rent rate, Java will not decide that rent rate has been initialized. So if you left rent rate here uninitialized, so no equals 0 here, just double rent rate, and you had if my age greater than 25, blah, 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 and you assign rent rate, and else, curly braces, and you assign rent rate something else. Even in that case, Java will not decide that you have assigned some value to rent rate. So as soon as something appears inside an interior scope, Java does not assume that it executes, even if it's in an if-else block where one of those two must execute. So that's really important because to you and me, if we see an if-else block, then we know that one of those two pieces of code has to execute, because whatever is in the if statement is a Boolean variable, so it is either true or it's false. So either the if conditional, the body of the if statement runs, or the body of the else statement runs. But that's only our human logic. That's not how the compiler is going to figure this out. The compiler is simply going to see, oh look, you have a conditional, you haven't initialized rent rates, so it's conditionally initialized. In fact, that's the compiler error that you will see. The variable rent rate is conditionally initialized, and it will give you either a compiler error or a compiler warning, depending on which compiler you have. So let's all assume that it's going to be an error and make sure that's not a problem in our code. Okay, is this clear to everybody? How do you guys feel about this? Great.
So you couldn't just put it for the curly brace
Or so you can put it under if, like somewhere under the if statement, and somewhere before the curly brace to initialize it. You would have to do it before the if statement.
Oh, no, it would have to just simply appear before the access. So if you could say double rent rate semicolon, and then say under here, rent rate is equal to 5. And then that would just basically always set rent rate equal to 5, and it would always print out equal to 5. And there wouldn't be a compiler error. Now, logically, we would want the if statement to control what the value of rent rate is, so that might defeat that issue. But there wouldn't be an error with that. That would just be a logical error, in the sense that you wouldn't be using your code to actually set the rent rate correctly. But that would not be a compiler error. Incidentally, that's one thing that I've only briefly touched on in this class, the distinction between a runtime error and a compiler error. And let's be clear on what the difference is. A compiler error is an error that happens when you compile. It's, in fact, the long form name for this is called a compile time error. A compile time error is simply an issue like type mismatch. You can't assign a double value to an integer. That's a compile time error. Another compile time error is that you don't have a semicolon, or you don't have matching curly braces. All of those are compile time errors. And they won't even let you run the code because you'll never even be able to compile. Now the difference between a compile time error and a runtime error is that a runtime error happens after you compile. The compile is just fine. But when you run it, it breaks. And it doesn't always break in the runtime error, but maybe even sometimes it breaks. So for example, when you have a scanner and the user types in something that is not of the right type. The user types in a bunch of letters when you need them to type a double. That will create a runtime error, and it will cause the code to halt at that point. It will crash. And it will say, runtime error, incorrect type from user, something like that. That code compiled just fine, and it might run just fine if the user typed in the right thing. So it might sometimes run and sometimes not run. But that's an example of a runtime error. Another example of a runtime error is if you perform any arithmetic that results in something illegal, like division by 0, for example, will generate a runtime error. A number of other things will generate runtime errors because they're not caught by the compiler. The compiler is not interested in values in your data. It's only interested in should this code work in terms of types, in terms of scope, and in terms of operator precedence and associativity. Yes?
Could you explain the example for runtime error again?
Yeah, so the example for runtime error is if the user types in an unacceptable type. So you guys have all used scanner and had the scanner, you've run like next double, next int, and every time you say, my scanner.next double, the job is going to pause and wait for the user to type in a floating point value, excuse me. And if the user doesn't type in a floating point value, if they type in letters or spaces, then there's no way for Java to convert that into a number. Java is simply going to choke and say, that's not a double, and then it's going to crash and say, runtime error, incorrect user input. I don't remember the exact runtime error wording, but what you should know is that this kind of thing can cause a runtime error. So another example of a runtime error is division by 0. If you divide by 0, that generates a runtime error. It's not a compile time error because dividing by 0 is a variable of totally acceptable type. Right? That 0 is an integer. It might have been dividing from another integer. Integer divided by integer is totally legit Java. But divided by 0 is a runtime error. So that's another example of how you can get a runtime error. Any other questions? Okay, interrupt anytime, remember, it's always okay. Okay, so we've talked now about scopes. Christian.
In that case before in the if statement, why wouldn't you just use the ternary condition? Or would you
here?
Yeah.
there's no reason why you wouldn't use a ternary conditional, except unless you needed to assign multiple values. If you were assigning multiple values in the ternary conditional, it looks really ugly, and you really shouldn't do that. So fun fact, you can make multiple assignments of the ternary conditional, I think, but you shouldn't do it. You know what? Now that I think about it, you can't. So you can only make one assignment. So actually, it would not be possible. Know what the ternary conditional is. I don't advocate that you guys code with the ternary conditional, but I advocate that you know what it is. So when somebody else codes with it, you should say, this is ugly code, don't use it. Okay, so far, this is our first example of a variable scope. So there are actually a few other instances where they are variable scopes, and technically you have seen them before, but we haven't interacted with them before. So I'm going to point those out now, and also explain when we're going to see other variable scopes. So actually that thing on the very outside of your code, public, class, hello world, all that those curly braces are a variable scope. And in fact, you can't even declare a variable outside of that class scope. But regardless, that's a scope. And when you have multiple classes in your software, then the variables of one scope cannot be visible in the scope of another class. So when we have classes, they define scopes. Another instance of a variable scope is the main method. So later on in this class, we will see other kinds of methods. You'll be able to define custom methods. But right now, the only method that we have seen so far is the main method. And the main method is also a variable scope. You can have multiple methods in a class, and if you define a variable inside one method, that variable is not visible in another method. So methods are their own variable scopes. And various variable scopes can be nested. So the scope of a variable nested inside one method, being invisible to other methods inside that class, makes it also invisible to other methods in a different class. Because that method is inside one class, inside a different class, you definitely can't see that variable because it's in a different class and it's inside a different method. Now there's ways that we can make these variables visible in different classes, but that's a topic for CSE 17. We'll touch on it briefly later. So the case where we have code that generates scopes are if statements and switch statements. So inside the if statement, the curly braces define the boundary of the scope. Inside the switch statement, the cases define the boundary of the scope. So imagine you had a switch statement where you had case 1, case 2, case 3, case 4. If you declare a variable inside one case, that variable declaration will only apply if that case is activated. If that case is not activated, then you don't have that variable declaration. And attempting to use that variable declaration in some other case, if that case hasn't been activated, results in conditional declaration issues. So the switch statement is a unique sort of variable scope in the sense that the entire statement can be one single scope in the sense that if you fall through to different cases, your declaration your variable stays declared. On the other hand, if you treat switch statements much like groups of if-else statements, which you should, then you should really treat the independent cases as separate scopes. At least act as if they are separate scopes. Okay. It's very easy to figure out exactly how variable scopes will interact with if statements and switch statements. All you need to do is take out your hello world, code a simple if statement or a simple switch statement, and change the cases around. See if the if statement runs, if the else statement runs, what happens with whether or not the variable is declared or not. Do you get a compiler error? Do you not get a compiler error? How does that happen? So a little bit of experimentation will make this immediately clear. Because remember that Java is totally consistent with the way that it works. There's not going to be exceptions with the way that it reads its own language. It's always going to treat the if statement in the same way. And once you have an idea how it works, that's how it works locally. Okay, so we will see other instances of scopes, in particular in loops, which we haven't seen yet. We'll see after the first exam. Loops don't really change the situation with variable scopes. So once you understand scopes for the first time inside an if statement, inside switch statements, then having them inside loops is not a lot more complicated. It's basically the same thing. And just to say it one more time, scopes can be nested, they can be infinitely nested. So you can have infinitely nested if statements, and you can declare things inside those nested if statements, and each one of those variables at the different levels of nesting will not be visible outside of that level of nesting. And if you nest it inside one scope and then come out, and then you have another bunch of nested scopes that are not inside the same scope, nothing inside the second set of nested variables, nothing inside the first set of nested scopes will be visible inside the second level of nested scopes. So just because they're at the same level of nesting doesn't make them visible to each other. They have to be inside the same scope in order to be visible, or exterior to that scope. Okay, so that has some implications for how we should write code. The existence of variable scopes has some implications for how we should write code. The way that we do this is that we should declare variables in the scope where they're going to be used. We should avoid playing games with where we declare the variables if we have them too far out. So what you shouldn't do is you shouldn't have all your variables declared at the very beginning, because that makes it hard to keep track of what your variables are. Right now, the code that you're writing is a little simple, so it's easy to just look at the top of the screen and see what variables you've declared. Once you start writing more complicated stuff, if you insist that your variables are at the top of your main method, then you're going to have to scroll up really far and remember what those variables are, and that leads to bugs. So any way that we can simplify the process of writing code is good, and we can do that in particular by declaring variables in the scope where they're used, and never outside the scope where they're going to be used. Because what that helps us do is it helps us contain our variables. If our variables are in the scope where they're used and not outside, then you can't accidentally write a variable with the same name that has values that interchange with the variable you declared. It keeps your slate clean for where you're working. So that's another important thing. If you have two different scopes, you can declare the same variable with the same name in a different scope, and they won't conflict. So if I have one if statement, and I declare a variable inside that if statement, and then outside that if statement I have another if statement, I can have a variable with the same name and type, or the same name and a different type, declared inside that second if statement without having any conflict. So this is a really nice thing about variable scopes, because there are some variable names I want to use over and over again. Like later on you'll see that when we use loops, it's helpful to have variables that are always called I, J, and K. When we have variables, it's sometimes helpful to have a variable called X, or a variable called var1. These are useful sort of generic placeholders for just temporary values that we're working with, and we're just sort of putting together a bigger expression. When we have that kind of data floating around, we don't want to accidentally use an old var1 that was left over from some old piece of the code, from some earlier piece of the code, and have it secretly containing a value that we didn't want to use. That can cover up an error that we can make that can be hard to find later. So a great example of that would be, suppose I accidentally forgot to initialize a variable that had the same name as a variable that I used a long time ago. I might use the old value in that variable, and as a result have some completely wacky outcome, and it would be difficult for me to find that, because I'd have to sort of trace the values back and realize, oh, sometimes this variable contains the old value from this variable a long time ago. And that can only happen if I'm declaring variables in scopes outside of where they're used. If I'm only going to use a variable in the scope that I'm working in, my workspace scope, then I never have this accident of other stuff from the outside polluting what I'm working on. So always declare variables in the scope where they're used. Never declare them outside of scopes where you don't, outside of the scope where you don't never declare them in scopes where you don't need them. Never declare them outside the scope where you're going to use them. So there's a certain strategy to this. As you write more and more complicated code, it will be natural. It's not too weird a thing, and I'm sure there are some of you sitting in the audience like, stop talking about this, it's so boring. But this is something that if you have some strategy to it, some artfulness to it, the way that you declare these variables will make the process of writing code easier, and it will avoid simple human errors that we all make. Okay, so there's a term when we use variables of the same name that we should be aware of. And that's the term variable shadowing. Variable shadowing is when I have a variable that's declared inside a scope, where inside that scope there's already a variable outside that scope that has the same name. So if I had double run rate outside the scope and then I declared another double run rate inside that scope, this particular error would be called shadowing the rent rate variable. Because I've got the existing rent rate and it sort of casts a shadow inside the scope, because if it's been declared outside the scope, then it exists inside the scope. And if I try to declare a new one in its shadow, then rent rate would be doubly declared. You couldn't shadow that variable. There are some languages where shadowing variables is okay. And that leads to a different situation where inside the scope, rent rate is equal to whatever value assigned inside the scope, and then outside this scope it becomes equal to what it used to be assigned to. That's not something that Java will let you do. Java does not permit variable shadowing because it's really easy to code errors in that way. So be aware of this, and if you should know this terminology. It's called shadowing. Yes?
How is that different than the?
It's handle, right?
Yeah, whenever we set it like to 0 outside of the if statement. Or whenever we set like I forget what the example was, but it was like with renting the car and the age. How is this different than whenever we set it to 0 on the outside, so that it would not have an error?
So this is different because we've declared it twice. And the fix to the earlier example was not to have it declared inside. So if you had double run rate equals 25, and this wasn't a declaration, this is just an assignment, run rate equals 35, then that wouldn't be variable shadowing, that would just be assigning it inside the scope. That's just a conditional assignment. But if you shadow a variable, that's declaring a new variable inside an internal scope. And in Java, that's not allowed. In other languages, it is allowed, and it's a distinction between Java and other languages that it's useful to know that term for. Okay. Before I go into debugging, does anybody have any questions about what we talked about so far? Christian?
Yeah, I'm having trouble wrapping my head around why you shouldn't declare on top, because I have like a habit of writing like my variables and then setting it to like 0, so then I know that they're gonna be switched. So like, for example, the Yahtzee one, I have 5 dice.
Sure, right. It's really natural to have those at the top. Right? Yeah. So in the Yahtzee example, you almost can't escape having those variables declared, not necessarily at the top, but close to the top, because you are using those variables throughout the whole code. And there's a lot of code that comes after it. In fact, I think the Yahtzee assignment is the first time you guys have written a long piece of code, which is a great experience for you. This design criterion that I'm trying to explain is more that you shouldn't declare variables at the top when they only get used in one place in the code. So, for example, when you're in the Yahtzee example, when you are solving for the the number of threes of a kind. You don't need to declare the number of three of a kinds in the very top of the main method, because you're just not going to use that until you get all the way to the point where you're counting three of kinds, right? With all the if statements counting three of kinds. So you should only declare it inside the place where you're calculating the lower section score, because that's where you're using it. So it's true, the lower section score is not an internal scope. It's just like the second part of the code, right? But inside the lower section score, you've got a number of different scores to evaluate. And having all those declarations right in that area means that when you're working on this code, you don't have to scroll all the way to the top to remember the name of your variable. And just that action, saving you the need to scroll up, is going to, A, make you work faster, just because there's less scrolling. And B, it's going to avoid small errors that can occur by just slightly incorrect number. And these little things where we write our code to avoid doing the tedious mental work of remembering little things and scrolling and other little things is the difference between having good code that doesn't have bugs and code and bad code that does have bugs. Because in one case, the developer is working a lot harder to get the same code. And when you're working harder, you're more likely to make error. So one thing about writing code, which is actually very similar to just writing in English, is that we're writing to read the code ourselves. It's not just for the computers. And thinking ahead of that problem, like how can I write this so that I will understand it better, is a meta way of avoiding bugs. And that's what I'm trying to say here. Like, yes, you could in theory take all the variables that you want to use in the Yahtzee. In fact, the Yahtzee example is a really good example. Like in the Yahtzee example, you've got dozens of variables, right? How many of this, how many of this, how many of this? You can put all of those variables at the top. And then as you write your code, you have to just constantly scroll up and remember what you call that variable. Just putting the declarations in the right place reduces that cognitive load so that you don't have to hold as much as you go. So that's an argument for why you shouldn't do it. It's not like Java is going to stop you. You can do that, and in fact, some programming languages insist that you have all the declarations at the top. But Java is just going to be like, all right, well, you declare all these variables. The computer doesn't have any problem remembering lots of different variables. It's solely for us. Yes. Oh, what's your name? Amy.
So is variable shadowing, like, is it not an error?
No, variable shadowing is an error. In Java, it is an error. In other languages, I'm sorry that my memory is slipping. I don't remember what languages it's okay in, but variable shadowing is not okay. Christian.
How does that play with like our initial like advice, which is think about how the code would work versus like setting like the variables at when
how does the location where we declare variables?
Like
that's a fantastic question. So when I think about code, first of all, I don't think about code. I think about algorithms. So the difference is not code and algorithms are different in the sense that algorithms are the idealistic way in which code works, and code is actually what is being written in the file. So when I think about algorithms, I think when I think about the Yahtzee homework, I think about it basically like, okay, I've got the upper section process, the stuff I'm going to do for the upper section. I'm going to calculate all that, and then I'm going to calculate all the lower section stuff. And then I'm going to get whatever the total is with the bonus, and I'm going to add it to whatever the total is for the lower section, and that's going to give me the final result. So that's the overall picture that I have, and then for the upper section, I think of it as like, okay, well, there's like 6 big calculations. Count the number of 1s, 2s, 3s, 4s, and then figure out if the bonus applies. Which apparently the bonus never applies. I'm sorry, but okay. So I imagine that as basically 6 declarations with some calculation involved for each one. Actually, a bunch of if statements, and that's going to give me the final value. So when I think about it, it's basically like it's basically like a bunch of scopes. I have, it's not really a scope, like a bunch of sections. Like I have a section for the upper section. The upper section is divided into 6 little pieces. I add the total together. And then when I think of the lower section, it's its own section. It's also 6 or 7 little pieces, and I add them all together. They're not little pieces, the lower section is like big pieces actually, but I add them all together. And when I think about a section, that's where I have variables declared. Because for each section, I'm not going to use the variables in that section in some other place. Like inside the upper section of code, whatever variables I'm using there are going to stay there, except for the grand total, basically, or for the upper section total. And same is true for the lower section. I'm going to have whatever I add together for the lower section to give me the lower section total. And the only thing used outside of those 2 sections is going to be the upper section total with bonus and the lower section total added together. That's how I think about code, and that organization drives where I put the variables. So I'm only going to put variables in the section of the code in my mind where I'm going to use them, and I'm not going to put them anywhere else. Now, as I code it, I might realize, oh, you know what, actually, I have to use this other variable. For example, I have to use the value of each dice all throughout the whole code, right? So I might not have thought about that, like I didn't think about that when I first described the sections in my thinking. So now, in hindsight, actually, there actually probably has to be the variables describing the values of the dice in its own section in the beginning, where I use those variables throughout, but then all the other variables are in their own sections. So, and this is the way that we code, right? We don't write code from top to bottom, we write code in different sections, and sometimes we edit earlier parts of the code, remembering, oh, we need to carry this first. Okay, so have a look at the debugging slides. It's more of a qualitative thing, so just be aware of